surveying, metrology and related fields, we work with spatial measurements, distances, angles, directions and more. We call these measurements observations. Adjustment is a mathematical process we use when we have more observation than strictly necessary, what we call redundant measurements. Adjustment answers three critical questions. What are the most probable values? How uncertain are those values? And how well our measurements agree with each other? In practical terms, adjustment combines multiple imperfect measurements to extract the best possible answer and quantify our confidence in that answer. Let me give an example. Suppose we want to measure the length of the wall using a measuring tape. We make several readouts and we notice something immediately. The measurements aren't identical. Let's say our measurements are, the first measurement will be 5.1 meters and the second 4.9 meters. Now we face a problem. The wall hasn't moved, but we have two different answers. What is our best estimate of the true length? We could arbitrarily choose the first measurement or the second, but that would ignore valuable information. Our intuition tells us to take the average. It seems reasonable, but here is the critical question. Can we prove this is the best answer? And even more important, how confident are we in this result? Let's complicate the scenario. What if our measurements include outliers or errors? Should we still take the average? Or what if we have 100 measurements? The average may still be 5 meters, but we should be more confident in this answer because we have more measurement clustering around the same value. This is why we need adjustment, to rigorously answer questions like what weights should we give to the different measurements? How do we handle outliers? How do we quantify our confidence? What if measurements have different precisions? But there is another problem. This example is actually too simple. In real engineering scenarios, we don't measure a single quantity where arithmetic mean might work. Instead, we typically measure multiple types of observations simultaneously. Distances measured with laser tracker or total stations, angles measured with a theodolite, height differences from leveling, and vectors from GNSS GPS. Also, we want to determine multiple unknowns like XYZ coordinate. We have geometrical constraints. For example, three angles in a triangle must sum to 180 degrees. And we use instruments with different precisions. Like this, we establish what adjustment is and why we need it in real-world scenario. In this video series, I'm pleased to cover all fundamentals of adjustment of surveying data.